Alright, the interesting and scary thing about C is that you can actually directly manipulate memory addresses. So this is something you can't really do in Python. Okay, and pointers are what you use in C to do so. So pointers are variables that actually store memory addresses. Okay, so you can use the star or indirection operator to access the memory location that a pointer points to. Okay, and setting the value means the typical value something is wrong is null. Okay, there's null pointer. So what's the point? The point here is that when you pass an argument to a function, the function will make a copy of the argument. That's not always what you want. So this is called pass by value. So sometimes you want to pass something to a function to modify and need some way to do it, right? So pointers are actually addresses. Okay, let's take a look at this example. So for example, we do int x equal to 5. So what really happens is that there's some memory address in the computer which is actually bound to x. Okay, and now inside there it's 5 so it's cool. Now, so if you do print n x, okay, ampersand x, and then kind of like percentage p, this nx gives you the address of the variable x, okay, which is this thing, and percentage p prints it out and it's a pointer format. So this is what you get, okay. Now, suppose you do star y, okay. What this means is that y is actually a pointer. It's a pointer, okay. What y stores is not so much a variable, but it's actually a memory address to an int variable. So, and then what you can do is you can do y equals to ampersand x. It means now y is now at this address, but the value is this thing, which is the memory address, okay, of x, okay. And now if you do printf, percentage p y, you will get the same address because it's storing the memory address of x. Okay, now if you do printf, okay, star y, what this thing is that this goes to gets the value of the memory address of y. So that means y goes to this thing, and you get star x gives you the value stored at this memory address, right? So it's 5. Okay, and if you do print ny of this, you get this thing because y is a different memory address. All right, if that isn't confusing enough, let's look at another example. Okay, so if you remember x and y, this is the result of x and y from the earlier part, right? So now we do star y plus equals to 1. Okay, what happens here? Well, star y is this thing, okay, which is actually x. And then you plus equals 1, you change x to 6. Okay, then you do int star star z. Okay, and z is equal to n of y. So now z is a new variable. It now points to the memory address of y. Okay, and x and z is what? Star star, okay, int, which means what? It's a pointer that points to a pointer that points to an int. All right. So if you do printf of x, okay, d, you get 6 because this is what's happening inside here, right? 6. Okay. Now, if you go and print the pointer z, okay, then you will point to this thing. So it's actually this value. Okay. Now, if you print the thing that z points to as a pointer, you are printing y as a pointer, so you get this value, right? So it's good. Now, if you do the pointer to the z, and then you print the d, you will have 6 because that's what it is. Now, if you go and find the address of z and you print it as a pointer, you will get this address, which is the address of z. Okay, hopefully this helps you understand. This is a little complicated, but it's what you have to deal with if you do with C. There's actually more stuff, but we just do an overview of pointers here. Okay, let's test if you understood what we just did. So let's look at this function main. Okay, in x is to 9, very good. So x is now set to 9. You print f, okay, and x p. So you're printing the memory address of x. So know that this is actually the memory address of x. Okay, and what you do, you pass value x. Okay, so x goes into pass value. So pass value now, this value must be 9, right? Because x is 9. Okay, so what we do, we printf the address of 9. Okay, it turns out that this thing is now the address of our val. Okay, and this is different. You see, this is DC, this is FC. So actually, when this x is actually here, and this val is a different memory location. Okay, now we do val plus plus. So val has become, then you print the val, so it's become 10. Right, so this is actually here. Now, after that, you print x again. Now, what happens? X is still 9, right? Because it's still the old stuff. It's a different memory location. Now, if you pass the address of nx, okay? So over here, it's actually you pass in the address of 9. So the thing that's passed in here is not 9, it's passing in this value, right? This value is going into pointer. Okay, when you print the pointer, you will see this thing because it's exactly what you passed in. Okay, now you pointer plus equals to 2. What is happening? You're adding 2 to 9, right? So it's 11. When you come back out, you print again, this would now be 11. Okay, so this tells you that in order for you to modify variables, you need to pass by reference. That means you're passing in a pointer instead of passing in a value. Okay, next question is how do you actually return multiple values? So what you can do is that you can declare the variables in the caller to hold these values, right? And then you pass the address to these variables, and then essentially in the function you will just return by actually writing into those memory addresses. Okay, this is how C does it, and it doesn't use the return keyword at all. Okay, then the other way of doing it is to return a collection of data, like a struct array. All right. So you can abuse pointers. If you do these things like in star n, okay, so this you're actually allocating a new pointer to an integer. And now you can, by fiat, allocate n to 25. It means you're pointing to the address 25. And then you try to print whatever stuff at 25. Okay, what happens? Well, I will leave you to go and try this out. Right? So bad things happens because this means that if you allow you to do this prop, that means that you can technically go to any memory address in the computer, which is really nasty, right? Okay, so try this out and you see how it blows up.